Hello friends, today we are going to study electrochemical or electromotive series. As per the Nernst theory, as you know, when any metal is dipped in its own solution, there is a formation of electric double layer, and because of this formation of electric double layer, there is a formation of electrode potential. So here, this property for metal to metal is different. That means every electrode has different electrode potential, and all these electrodes therefore they are arranged according to their electrode potential in a particular series, in a particular manner. They are called as electrochemical or electromotive series. Let us define first it. So by the definition, it is the series in which electrodes are arranged along with its or their electrode or Huxell reaction and standard electrode potential according to decreasing order of standard reduction potential is called as electromotive. Okay. So here let us consider how the electrodes they are arranged according to their standard reduction potential. This standard reduction potential can be symbolically represented for our convenience like E0, that means standard conditions, that is the molar concentration is 1 at 1 atmospheric pressure and temperature should be 25 degrees Celsius, that is 298 Kelvin. Okay. So here let us consider how the electrochemical or electromotive series is first. Here you can write here electrodes. Okay. Then half cell reactions, and then the reduction or standard reduction potential also denoted as E0 reduction. Okay. Consider one by one. So here the extremely there is a fluorine electrode. The platinum is in contact with chlorine gas, and further it is in contact with the solution which contains the chloride ion. Similarly, chlorine electrode or some silver electrode or some copper electrode. It means copper metal is dipped in its copper solution, or some platinum electrode where platinum wire is in mercury and it is in mercurous chloride, and further it is in contact with the chloride ions. And here the hydrogen electrode with the platinum plate and its contact with hydrogen like this. So this is the electrode special importance because it is used as a standard electrode. primary standard reference electrons. Okay. Similarly, there are number of electrons. For example, iron electron or some chromium electron, tripositive ions are there, or some zinc electron is also there. Similarly, some aluminum electron or some magnesium is deep in its ions, magnesium ions, or sodium electrode, deep in its sodium ions, or some calcium is in a calcium ions, potassium in a potassium ions, or some lithium. This is the electrode having. Now, consider their half cell reactions. That means how they act. So here, chlorine plus 2 electrons give H minus ions. Similarly, chlorine plus 2 electrons give chloride ions. Silver ions will absorb electron undergoing. All these are the reduction reactions where the absorption or addition of electrons taking place. And now this is the mercurous chloride, giving electrons giving twice H plus twice Cl minus. So this is also reduction reactions. Here again, this is a specially important electron where the used as a standard reference electron. Okay, but first write down all these reduction reactions. First, okay, chromium, tripositive ions, electrons, chromium, or zinc, 2 electrons, zinc, or aluminium, plus 3 electrons are there. Aluminum is forms. Similarly, the magnesium electrode, sodium electrode, calcium electrode, and here potassium electrode, calcium, and this is the lithium ion absorbs 1 electron. Now, here in this case, consider so here reduction potential of this. As discussed, this hydrogen electron is taken as a reference electron, and when compared to the hydrogen electrons, the electron potentials of all other electrons are determined. Okay, and for this hydrogen electron, the potential is considered as 0 because whatever electric double layer is formed when hydrogen gas is adsorbed on a platinum plate, the potential or the ionization is very, very small and it is nearly equal to 0, and further it is considered as a 0 volts are found. Okay, so here with compared to the hydrogen, if this hydrogen electrode is attached with all these electrodes, it is found that all these electrodes they undergo the reduction and these electrodes undergo oxidation. So here the reduction potential or tendency to undergo the reduction is more with compared to the hydrogen, and they have therefore given positive values. All these electrodes. Whereas if these electrodes are attached or joined with the hydrogen electrode, it is found that these electrodes have no tendency to undergo reduction but the preferred oxidation. Therefore, if you consider the reduction reaction, they have given a negative value. All these have negative values. The negative value of reduction potential. Standard reduction potential means they have less tendency to undergo the reduction with compared to the hydrogen electrode. And for this, if this is a lithium electrode having 3.04 volts, this is of course the 92 volts is there, 2.87 volts, 2.71 volts. This is the magnesium electrode and it is given as 2.37 volts. This is the aluminum electrode, 1.66 volts. This is the zinc electrode, 0.76 volts. This is the chromium, 0.74 volts, and for the iron it is 4 volts. So all the reduction potentials for this is given. For this, the positive value indicating they have a tendency to undergo the reduction with compared to the hydrogen. So here this has 28 volts. Okay. Copper has 0.799 volts, whereas silver, this copper has 0.799 volts, and this copper has 34 volts. Fluorine has 1.36 volts, and this is the fluorine electrode having a maximum reduction tendency, and it has a value 2.87 volts. Okay. So these are the standard reduction potentials, that is E0, E given in volts. Okay. So here consider further. So this is the electrode series in which electrodes are arranged according to their decreasing order of standard reduction potential. Now here this is the hydrogen electrode is considered or taken as standard reference electrode and given a value 0 volts. Okay, and we compare with this hydrogen electrode, they have different values. Okay, and it is given here. So here all these electrodes here they have a higher value of E0 reduction, that means standard. That means they undergoes reduction. They have tendency to undergoing the high tendency of the means. That means they have high tendency of reduction. For example, if you consider okay, in short, okay, all this, if you consider these elements, all they have low values indicates or means they not or less tendency. They have less tendency of reduction. But they prefer to oxidation. Okay. Now if you consider this element, so instead of formation of the lithium from lithium ion, it preferred the formation of lithium to lithium ions. Okay. Now here all these values are according to or with compared to the hydrogen electrode. With compared to the hydrogen electrode, they have negative values. That means, and this is a very low, right? The reduction potential of this electrode is very low, indicating this electrode not shows reduction, but it shows the oxidation. It preferred the oxidation. In that, or in this case, this is the electrode having the positive value. That means it preferred reduction. Okay. Now we are going to study the different applications of this electromotive cells. Okay. Different applications of the electromotive cells. First thing, this from this electrochemical series, one can decide or one can calculate the standard potential of cell. Okay. So here the standard cell potential can be calculated. Right? Cell potential that is can be denoted as standard, and what is cell? What is cell? Of course, the electrochemical cells, and electrochemical cell is made up of two electrodes combined together. Okay. So here also whether the reaction is taking place or not taking place can be determined, can be decided from this. Okay, how? If you consider one of the example. Consider example. If you consider a Daniel cell, what is that Daniel cell? One can be represented like this. Zinc is electrode is weak and separated by here copper electrode in there copper ions and this. So here this is the anode, oxidation taking place, and this is the cathode, the reduction taking place, and therefore the zinc giving the zinc electrons. So this zinc electrode is there is a solid bridge and attached to the copper electrodes. Okay. So this is the representation of Daniel cell, and if you consider the half cell reactions here for this E0 oxidation, okay, E0 oxidation is equal to. So what is the oxidation? Now if you consider this zinc electrode, this is the reduction potential. It is a minus 0.76. Therefore oxidation potential, or one can write step by reduction is equal to minus 0.76. Therefore E0 oxidation is equal to plus 0.76 volts. Okay. Also, if you consider this copper electrode having the reduction taking place and having copper, and here the E0 reduction is equal to if you consider the copper electrode, this is the reduction process and having plus 0.34 volts. So here by the definition, E0 cell is equal to E0 left hand side oxidation potential minus E0 that is standard electrode potential, oxidation potential of the right hand side is equal to this, or this can be also written as E0 cell is equal to E0 oxidation minus plus E0 reduction potentials of the right hand side and left hand side. So using these two reactions, one can find E0 oxidation left hand side. So this is the electrode where oxidation taking place. It is always written to the left hand side, and its oxidation potential is 0.76 volts minus the right hand side oxidation potential. So this is the reduction potential. Its oxidation potential is equal to minus 0.34 volts. So here it becomes minus 0.34 minus into minus plus, so it becomes 1 volts. Right? So here this reaction, this is the E0 oxide. E0 oxide. Okay. Here or also here, this can be the E0 oxidation of the left hand side, that is 0.76 volts as usual, plus reduction potential is 0.74 volts, this is equal to 1.10 volts. Okay. Plus. Anyway, we can use anyone. So what we get from this? Okay. Now, if you consider for this type of the redox reaction in an electrochemical cell, there are two reactions. Suppose consider now again. Now in this case, consider the Zn giving Zn plus electrons, or copper giving copper plus electrons. So this is the, again, this is the E0. This is the oxidation process. So here for oxidation of this Z is, what is it? Plus 0.76. Okay. If you consider the reduction of this copper, okay, and the copper, so this is the reduction type of the cell, and it has given value is plus 0.34. If you add this, net shell reaction will be Zn plus copper giving copper plus Zn. Okay. And therefore E0 of cell is equal to the reaction is plus 1.0 volts. Okay. Now consider this side also. Consider this side also. Process. Consider two cases. Here there is a Zn ions plus 2 electrons giving Zn solid. So here this is the oxidation process. So here E0 of this copper oxidation is equal to, in this case, so you know this is the reduction process, it is the plus sign. So for the oxidation it will be a minus 0.34 volts. Okay. And for this is the reduction process, and for this G it will be minus 0.76 volts. If you add, you get E0 of cell is equal to, by the formula, so it is minus 1.0 volts. Okay, and the net shell reaction will be copper plus zinc ions with the copper ions plus zinc ions. So here, as you know, very it is a low value, that is negative value. Okay, negative, a low value. That means therefore this reaction is not taking place, because E cell, that is E of reaction is equal to minus 1.1 volt, and however this value is high value, therefore reaction has more or high tendency to occur in a given direction. That means this reaction taking place very easily. Okay, so this is possible, but this reaction is not taking place because the E cell, because as E0 of reaction, that is E0 of cell is equal to plus 1.1 volts. Okay, so whether any reaction can be taking place or not taking place, can be determined or can be decided according to the E0 cell of whether it is a plus sign, it is taking place. Otherwise, if it is a negative sign, it is not taking place. Okay. So here the one can, this is a very important application of the EMF series. Standard cell potential can be also calculated, and on the basis of the standard cell potential for a given redox reaction, for a given electrochemical cell, for a given pair of electrodes, what types of the electrodes are joined together, then it can be also determined on the basis of their the net cell or cell standard cell EMF. Okay. Now third application. Consider. Now the reducing agent or oxidizing agent can be known from this. For example, consider extreme case here, the lithium. Consider lithium. Okay. Lithium. And its E0 reduction is equal to minus 3.04 volts. What is this is a very low value. Means no tendency. Lithium plus has no tendency of this reduction. But it undergoes, but what happens then? But lithium can be formed lithium ion and electron, and this is the loss of electron, that is the oxidation. Therefore E0 of oxidation is equal to, now the sign changes, plus 3.04 volts. So this is a high value. It means that means lithium undergoes oxidation and acts as strong reducing agent. What is the definition of reducing agent? That is a substance which reduces other itself undergoes oxidation. So here lithium undergoes oxidation itself, therefore it is a strong reducing agent. So one can write here, this is a very strong reducing agent. Okay. Now in this case, therefore it also can be written as this is a stable one. Okay, this is a stable one. So this stable cannot be with lithium. Instead of this is a stable. Okay. So this is stable and this reaction is fast, but this has less tendency to be occur. Okay. Now consider also one more example. Also, if you consider the extremely placed this electrode and this and E0 of reduction is equal to plus 2.87 volts. The value is high positive value means, what it means this F2 has high tendency of reduction. That is F2 acts as strong. What is that? The substance which undergoes reduction, so it is the oxidizing agent, right? So it is acts as a strong oxidizing agent. So here, this is the case. Now, one can write here, this is a strong oxidizing agent. Okay. This is the case oxidizing agent. Okay. So on the basis of this, one can write here these electrodes on there. They have this oxidizing agent. Okay, strong oxidizing. Whereas if you consider this side, this is a strong reducing agent. Because reducing agent undergoes oxidation, and the with compared to the hydrogen, which element is attached, it can be as the either oxidizing agent or reducing agent. For example, if you join this iron electrode with chromium electrode, then this electrode reduces and this oxidizes. If this iron electrode is joined with zinc electrode, then this electrode undergoes reduction. Right, in this pair, and it undergoes oxidation. So in this case we are going to study if zinc is coated on the iron undergoes reduction and it is not rusted. Whereas zinc undergoes oxidation, it goes to the rusting, it forms its oxide. Okay, so here the protection of iron is taking place. This is called as a galvanization. So galvanization process or any other like electroplating processes, which element acts as cathode and which elements act as anode, this can be decided on the basis of this electromotive cells. Okay. Now let us consider these are about the electromotive series. Now all these are different electrodes. So we are going to study the main electrodes. This is the standard reference electrode and this is the secondary standard reference electrode. Now consider hydrogen or the standard hydrogen electrode. Standard hydrogen electrode. Okay. Now construction. First diagram. So there is a platinum wire and it is sealed in a small tube. Here it is sealed here and it is not a continuous, it may be a break, and for this there is a mercury, right? There is a mercury for the connection and this is further attached to the platinum plate. Okay. And here then it is, this is the outer jacket. Okay. This is the outer jacket and there is a inlet for dry pure hydrogen gas, and it is always bubble at 180%. So this is outer jacket. Then there is holes. From these holes, the excess of hydrogen gas can be given out. Okay. Excess of gas given out. Okay. And this is in solution. Okay. So this is the very important, that is the platinum plate, or also called as the platinum black. Because of its appearance, the platinum powder is coated on the platinum plate and it appears black, so platinum black is also there. And the hydrogen is adsorbed here, double layer is formed, but it is a very small EMF is considered and it is said to be a 0. So here the solution H plus solution energy 1 molar and excess gas is given out. The electric double layer is here. This is the platinum wire, and this is the inner tube containing this wire, and this is the outer jacket. Okay. So this is about the construction. Now, what is the representation of the electrode? So here, platinum wire is in contact with the hydrogen gas, and further it is in contact with the electric gas. Okay. So this is always one molar is taken, and the hydrogen gas is 1 m. Or also it can be written as H plus 1, this H2 gas, it is 1 atmosphere, 1 molar, and further it is in contact with the platinum. So here the reaction. Now, if the electrode acts as, where the oxidation taking place, acts as a anode, right? When acts as anode. So what is there? Anode. There is a oxidation taking place. So what is oxidation? That is the hydrogen, giving 2H plus 2 electrons of electrons. Okay. So this is the gaseous hydrogen potential, and this is forms given solution. Or if the electrode when acts as cathode, that means reduction taking place. So here the 2 electrons are absorbed and this forms. Okay, so this is a representation of the hydrogen gas electrode, and these are the reactions if it acts as a anode or it acts as a cathode. Now consider the advantages of electrode. First, this hydrogen electrode is used as standard reference electrode, standard reference electrode, and it has given electrode potential of 0 volts. Okay. And third, it can be used entire range of pH. Now there are also some limitations. First thing, that is it is not handy. First thing. Secondly, there are difficulties occurs in to obtain first dry and pure H2 gas. Okay. Also, there is a difficulty to maintain 1 atm pressure of H2 gas. Secondly, the hydrogen itself is explosive. And nextly, sometimes this platinum plate can be deactivated by absorption of impurities. Okay. So in this case, this is there, and also one more, that is the limitation that is the concentration of 1 molar HCl, that is the activity, is changes during use. Okay, so these are the limitations, and because of these limitations, this reference electrode is replaced or substituted by a new electrode, and that is a calomel electrode. Let us consider this calomel electrode. Okay. So this is called as a secondary reference electrode. This is a secondary reference electrode, and its here electrode potential of this calomel electrode is calculated or determined by comparing it with the primary standard hydrogen electrode. Okay. So here consider now standard calomel electrode. Very simple in construction. First, so here there is a platinum wire and it is sealed in a. Okay, so this is an inner tube, and there is also outer tube is there, and at the bottom there is a mercury there. This is a platinum wire, and here there is also for the connection. Okay. So this platinum wire is sealed here. Okay. So here electricity, and this is also it. Okay. This is a platinum wire. Okay. It is sealed here. Okay. This is a coil, and there is a side tube for giving KCl solution, and there is also again there is a side arm tube where there is a solution of KCl is there, and here there is a Hg2 Cl2 plus Hg, what is called as a calomel paste is there. Calomel is called as a calomel. So this is the mercurous chloride is dissolved in this, and this is the, and now this is the KCl solution. Now this is the construction. Here at the end there is a glass plug. It is a glass plug. Okay. So here the advantages of the electrode. So it is a secondary standard electrode, and it is a reproducible EMF. Third, it can use over the entire range of temperature. And fourth, that is, it is handy. Also, it is simple in construction, or it can be prepared easily. Now, only one drawback is there. We are going to study here, and it is that drawback of calomel electrode, and it is that it has different electrode potential with different concentration of this. Example, that is there is a 0.1 molar KCl or some 1 molar KCl or some saturated KCl. Then the reduction potential, standard reduction potential for this 0.1 molar is said to be 0.33 volts, here it is 0.28 volts and 0.24 volts. That means, so in this case we have studied the some types of the electrodes. This is the secondary standard electrode, and these are these applications as well as the different limitations and products. Now, what is the use? How they are used? If we consider any electrochemical cell, now suppose this is the any solution, and there is suppose zinc electrode is there, and suppose this is the caramel electrode having and its side to this like this caramel. So what is the cell forms? Of course, zinc in zinc ions, and this is the KCl. The iron used as salt bridge. So this is the one of the advantage, right? This is the one of the advantage of this. That is the sixth advantage. It has side R containing KCl, and therefore acts as salt bridge. So here there is a salt bridge, of course the KCl salt bridge. Okay. So here this cell can be represented as, so this is the caramel. Or one can write here the platinum is in contact with the mercury and it is contact with mercurous chloride. Okay, and it is in contact with the Cl minus. Okay. So in this case, E0 oxide is equal to E0 oxidation of left hand side minus E0 oxidation or plus E0 reduction. You can use any formula, right hand side, or this is equal to E0 oxidation is of course the 0.76 volts of this G, and plus E0 reduction for the caramel if the 1 molar solution is used with a 28 volts molar positive, and the answer we can obtain the E0 oxide. Okay, dear friends, we are going to stop here today. Thank you very much.